This
fantastic show
conference
today.
will now be
And,
recorded.
oh, I'm listening to the lady say it's being recorded. That's wonderful. So we have another Cube Corner great show today. Today, it's a huge international community. We have all the way from Czech Republic in Prague, Adam Mazus, who's a specialist or an expert in storage. Okay, so this is gonna be really a treat. I know that in the past we've kind of discussed various things at a kind of higher up level. Now we're going to talk about storage. He's got some interesting stuff to say about that. As always, though, we want to know who we're talking to, right? And so I'm going to introduce Adam Azus. Take it away. I said you're in Czech Republic and Prague, beautiful city, one of the most beautiful in the world. So right away, we're all very impressed. But why don't you tell us a bit about yourself and importantly, how you got into IT and how you learned about Kubernetes?
Absolutely. Thank you for having me here, Jeff. That's actually an honor just to be in one of the Veeam user groups. So yeah, as you already introduced me, my name is Adam Azuz, and I am a cloud solution engineer. I think storage is my specialist. It's one of my main focuses, but it's not the only thing that I care about within my role within my within my company. So my focus, I'm working in pure storage. I forgot to say that. You can see the logo up there. Um, and my focus is in a software-defined product called Pure Cloud Block Store. So this is where I'm getting my attention and my focus into Kubernetes, which is something also abstracting storage from compute stuff like that. And my role is a bit of a hybrid between dealing with engineering and also tackling customers and marketing external stuff. Internally, I'm testing, also documenting, building user documentations from reference architecture, white papers, anything has to do with translating what the engineering have been doing into something that is digestible for the community, for users, for customers to go and implement themselves, or just come back to us and us gonna go and deep diving them into this technicality issues they have or some designs they want to do. So this is my solution job I'm doing in Pure Storage. I think this is the present. Let me just take you
Yep. Yeah, like
by time
what was your
to
educational background? Were you born
yes,
an IT person or, you know?
yeah, that's interesting just to start because sometimes you forgot your track and you're just like, oh, how I end up here. So I had my bachelor in electrical and electronic engineering, and my major was in communication engineering, which is kind of it was touching the theory part more than the practical engineering side. So we had all this kind of semiconductor sciences and how the microwave work and antennas and waves and particles and Schrodinger theories, all this kind of sciences behind the engineering of communication, which I think leads me to diving into like why you're doing something, not just like let me just do it, and the how or the what. And then I had the pleasures to start my career in virtualization. So, and at the end of my last year as a senior, I had to choose which track I'm going to take, and I thought of networking. It's going to be a good thing. And within networking, I found myself like dealing with that at that time. It was I think 2013 or 2012, where I think the software defined revolution started. Like everything wants to be virtualized, everything has to be software defined, and I started with software-defined networking, and that time was VMware doing the NSX. I think that was the early versions of NSX. So I just jumped there, and my first, I think, project with I started with a private company that they're kind of a service delivery for HPE and IBM. So my technical side was like just dealing with HPE servers, then HPE storages, then IBM storages, everything from maybe people here would recognize HPE 3 bar, which is I think one of the you know it yourself maybe. I think
Veeam,
that's what got me.
Veeam exams, there was always an H3P par question. I always remember that, and I have to memorize it
Yes,
because I've never worked on it. So,
absolutely, yeah. And I think HPE 3 bar what got me into storage because at that time they had this new technology that you just taken a storage array, a bunch of disks, and they chunk them into small blocks that you can just tear down or increase or decrease based on this small chunks. I think the 1 gig of chunks, and then you can tear down by hot tier, cold tier, or mid tier. So your applications have like more access to kind of granular sizes of blocks rather than just RAID this of like or disk pools from like traditional legacy storages. I think fast forward, I don't want to take a lot of time just talking about HPA
Oh,
bar
go ahead.
because I think that's what really made me fascinated about it. I've been dealing with a lot of kind of disaster recovery and replication from an HPE perspective. And then I thought about it this way that I, and this is when I started to have the realization that every vendor they have their own kind of marketing name for a technology, but in the base there's someone who's doing the standards, right? And I think that's really good. That was when I started to realize it's not just don't get the product from a vendor doesn't care once you know the technology. So I've had my time learning all the replication technologies like sync, async, what is RTO, what is RBO, from what does it matter from an SLA business side, how does it matter from an application side, and why does the application matters. And I think this is what we're trying to do this session, is that we wanted to to explain or maybe help people who maybe come new into Kubernetes to learn why it does matter to just learn the foundation, and then you can apply whatever vendor you want to run your managed Kubernetes or your storage platform or whatever, once you know these core concepts.
Yeah, and it's interesting because your background is engineering, so it's that's giving you, I think it's perfect for storage, because storage and networking, I would say, when it comes to the world of IT, are areas where you have to be very precise. I mean, not that you don't have to be precise in other areas, but they're certainly, but you're also marketing, so you've got a personality too. Because I've met a lot of engineers who are pure engineer background, and they're great engineers, but when it comes to marketing, it's like, so you've obviously got more than just the engineering skills. Um, Also, when you mentioned about previous storage technologies, for me it was especially interesting when I started looking at, I think it was vSAN, VMware vSAN, and the abstraction layer. This is something, just because for me, I'm from the days when there were floppy disks. Okay, so storage was like, there it is, and then there's the big disk that, if you want to destroy your disk and you look at little record players. So the abstraction layer was something new, and the reason I brought that in, well, you mentioned HP, but Kubernetes, that whole thing just goes the next level. So
Yes.
you worked in virtualization, so that's pretty much the norm now for everyone who's been in the
Yes.
business for, I think, at least 10 years or 5 years. That's virtualization. So when did you first hear about Kubernetes? What interested you about it? And when it comes to storage, I mean, this is everything in Kubernetes is different. This is the thing that people seem to realize right when they go into it. So what was your experience with that as well?
Yeah, that's a really great question to just maybe laser focus on just the answer, not just go abroad. Um, so I think fast forwarding from that time when I was just dealing with just delivering the service, deploying the infrastructure, um, deploying the VMware, Hyper-V, whatever virtualization is gonna on top of that stack, networking, compute, and storage. I found myself in a stage that I need to know how to script stuff, how to put things together, because that's a huge part of where the whole IT world is going, for agility, for more business continuity, for the fast delivery of applications. And I took kind of a 2 years gap of working. I seeked my master's degree in computer science. This is where I think I learned a lot about coding, Java
Wow.
programming, object-oriented thingies that I think by the time now it's evaporated from my mind because I'm not really coding anymore, right? But you still stick to that, the programming mentality. Like if you have a problem, how are you gonna solve it? So that's something, I think, a skill that I just obtained, but I as a soft skill. But I think I forgot all the thing about the technicality around programming itself. But I think this is the stage where I start to learn about containers at the
Hmm.
beginning, because when you want to develop an application, there's two ways to do that. You have your developer laptop or a VM instance that runs on whatever cloud or managed service, or you can just containerize them and you just start like whenever you want to do some change, you just push the changes and then you run the container again and check your application is running or not. So that's abstraction, what the container is provided on top of the virtualization itself, that made me realize that there's something more. I think, and a year after, this is when I realized that there's containerization from an enterprise level, or even like from development. It's really tying down the development cycles into silos again. So because when you run a container in a virtual machine, you have to maybe that virtual machine or maybe that physical server is going to be go to another. You might just delete that virtual machine, or that physical server is going to go and expire, so you have to move that workload. And this is when I start like realizing there's something called Kubernetes that's been around for years and no one knows about it and just came popular suddenly. That's going to be the orchestrator for all that containers, whether they're going to be Docker containers or whatever runtime that's running them, right? I was lost, and I think I had this book next to me. So this book, I think, made me realize. I think maybe a lot of folks are gonna know it. The Phoenix Project. I
Wow.
think that's one of the books that I read before going into Kubernetes and learning what Div and Ops means together as a DevOps role or a DevOps as a workflow or a life. I think sometimes some people they think of it like a really a lifestyle to have within your daily working times. Um, this is just me knowing Kubernetes, and I learned about it. I learned how to deploy it. I think that was just some Ubuntu machines run your Kubernetes. That was I think 1.19 maybe. Very basic setups. I have didn't deal with anything. I know what is CSI. I don't know what is CNI, and I stopped there. And then I joined Pure Storage to deal with software defined in the cloud. And 2 years after, I feel like I'm dealing more and more with people who wants to migrate to or modernize their applications, and they want to get rid of all this databases or applications that runs on virtual machines. I want just to get into, okay, let me containerize so I can have the freedom, so I can have the agility of what containerization and app modernization is giving us.
Yeah, no, exactly. And what you said, I've heard so many times, especially you, because you've done some coding. And what a lot of people don't know, who are just pure, let's say, backup engineers, is that one of the things that developers loved about Kubernetes or containerization in general is that you don't have dependency problems. So in other words, if you're on a virtual machine and you're testing your application, and it needs, I don't know, a library 0.12, but then you want to test it with library 0.34, guess what? You destroy your virtual machine because dependency hell it's called. They don't. So with containers though, you can have your Jeff application here, a second Jeff application here, more modern using a different version. And so that makes life a lot easier. The flip side of that, what I've heard, I'm not a coder, is developers, they're not lazy, they work very hard, but they don't want to deal with all this, they just want it. They want it like delivered, a pie. So the DevOps is the developer is going to do their coding, but the ops person is going to bring them the, I guess, the container and whatnot. So a question to you, what was the hardest thing for you in Kubernetes? And that probably wasn't storage because you seem to know storage. What would you consider for you was the hardest or most difficult thing, or the thing that took the longest to learn?
I think this is not only a Kubernetes problem. That might be all the platforms problem that they still have is role access based
Oh,
control. Even though like it's when you read and you really apply a very simple example, it seems like it's easy. But when you're gonna apply it on enterprise scale, it's like, what is that? Who is reading this and who is this actually? So I think this is still my one of the hardest terminologies or maybe fundamentals because maybe I didn't give it a lot of time, and that's just a thick dip that it happened to me. What else? And the other problem I think with Kubernetes nowadays, even though, I mean, there's a lot of issues. I'm not saying Kubernetes is the solution because a lot of people think it is. We have to be kind of biased here. I know that it's Kubernetes Corner, but maybe I'm not going to be
No,
invited
that's
here
okay.
anymore.
We want ownership. We want people coming
Yes,
here to hear the truth,
absolutely.
not just Jeff saying, I
Yeah,
love Kubernetes,
I so I've never been from a customer side that I have to take care of a Kubernetes cluster, I have to maintain it or upgrade it or whatever. But I heard a lot of stories, right? And the stories starts with the staff, even though they're going to be like the infrastructure, the visualization admins, let's call them providers from now on, because I'm going to be going with this kind of examples most probably a lot. Every IT organization, every company, they have this provider staff, they be providing the infrastructure for development, for the business analyst, for other consumers of that, whatever they're providing, right? Let's stick to this kind of terminology. It's always hard for them to go from I you have a granular level on I'm creating something, I'm attaching it to something else, and this is how it's reading and writing. So that's thing, it's object A is the compute, object B is the storage, and then whatever is going to be between is going to be the networking, and that's it, right? When you go to Kubernetes, you have to understand a lot of other resources, a lot of other objects. Things start like to double and triple in the amount of things you have to create in order just to provide a simple thing, right? So this is kind of the first problem, which is I'm not saying that it's still the problem. There's a lot of solutions around it. There's a lot of workarounds. There's a lot of toolings, but it requires a lot of efforts and a lot of learning curve to reach the point where you're really gonna be easier for you to provide something to your development and just to consume it, right? So that's one problem. The second problem I think for myself when I started with Kubernetes is, and don't get me wrong, I still think what Kubernetes is actually doing now, I think for the past 7 years or 8 years, it might not be, we might just forget the word Kubernetes in the near future actually. So this is kind of like, let me give you my future prediction. I think I heard my manager a couple of months ago, he's mentioning this to me, and in another kind of wordings, I'm just doing my rephrasing now after I realize what is my thoughts around it. I think Kubernetes is going to be abstracted down and something else, or is going to be like hidden down the platform, and then there's going to be like this one thingy, which is I'm not sure what it's going to be, which it's just going to be on top and leverage the Kubernetes engine behind it.
yeah, yeah.
And I think this is what I'm looking forward to investigate, do my solutioning around, trying to participate and contribute to the community, and also what we're doing in this session is to bring people up to speed, because this is where I came from. I started with learning, really focusing Kubernetes I think 6 months ago or maybe less, which is like, it's not like laser focused, like I do that in my leisure time, I would say, because my role does not do anything with Kubernetes. Um, and this is what we want to do this in this session. Like
Yeah.
those people who's gonna hear with us live, or people who's gonna be hearing this recorded, we want you to don't get confused with all of this, because once you learn the foundation, just and then you start like building on top, you're gonna find your way wherever it's gonna be on a public cloud provider, or your managed data center Kubernetes, or it's gonna be a new platform that is gonna rise from nowhere, and you suddenly like, okay, I know Kubernetes, I know how to learn further.
Yeah.
So you have to start. It's not too late.
Yeah, it's
Yeah,
never too late.
that's never too late.
As I get older and older, I love hearing it's never too late, right? And
Yeah,
actually,
absolutely.
that
Yeah.
there is in fact already happening to a extent, because if you look at distributions like OpenShift or VMware Tanzu, that's what they're attempting to do. They're trying to put
Yes.
that abstraction layer higher up, but an abstraction layer which will cover up some of the more complicated aspects of Kubernetes so that more people can get involved with it. The one catch I would say, though, just from my personal opinion, is flexibility comes at a price often of complexity. And the reason I say that is before Kubernetes, I had to do some Docker Swarm because I had a project where I had to ASAP set up something and I need an orchestrator. And I thought I was going to do it on Kubernetes. And then I thought we'd read over the weekend and Monday do it. And that didn't happen, obviously. So I was able to do Docker Swarm and it was easier and I got it up running. But then when I started to read about Kubernetes, I saw that, well, why is this part here more complicated? For instance, storage. Well, because you can do this, that, and the other. So in other words, you can shape this, sculpt it much better for whatever your particular needs are. So perhaps maybe for small business or really small shops, edge, they will need that kind of encompassed,
Yes.
solution, which is taking away all the complexity. But I still think that it's complex in the sense it takes a long time to learn. But once you get, like now I'm feeling much more confident. I still don't know a lot. But bringing this back to storage for a second, if I understand
Yes.
it correctly, and I don't, claim to know everything, and neither does my teachers or anyone I work with. But so originally, as I understand it, I could be wrong, the Kubernetes, all the storage was in tree, I think they say, in tree. And what they found out was this is not scalable. You have a million vendors out there, a million different types. So we're going to create this thing called container storage interface, which for people from the Microsoft world or other worlds is basically a plugin, right? It's a plugin so that vendors can create something and you plug it in. I'm not a programmer, so this might sound whatever. So what do you know about that? And what is this given to Kubernetes in the sense of possibilities and ability to scale?
Yeah, that's a brilliant question. I think so. This is where we go into another segue here in this session. Like, why what is new with Kubernetes and how we solving the storage with Kubernetes storage, right? And actually, maybe we're just gonna go like do one more point. It's why
Sure.
does Kubernetes storage matters, right? Because one is your application might not be a web server that just responding to requests and sending responses, right? That think about it like a shopping cart. Like shopping cart, it's you don't need to persist the data that you're serving and you're sending to your customer, right, or to whatever users is using the service. And the problem is when you think about it, there's always the need for persisting the data, right? So you always have this a container, let's call it a service or a process that will receive a response, and maybe they're going to serve you with a request from a data shared between a lot of from previous sessions, or maybe from a database, relational, NoSQL, Key Vault, whatever your installation was. But so we need that stateful in the application itself. So, and then there's a lot of ways we're gonna be tackling them. Maybe we're gonna have some time to look at my slides I prepared.
Oh,
Maybe it's
definitely.
gonna give
Well,
some.
right after this,
It's
we can
gonna
do a slide.
it's gonna it's gonna give some color to people here. But let's talk about Kubernetes storage interface, container storage interface. So there's a couple of volume and storage types that Kubernetes is offering, and I promise the audience that we're going to go through them all. But however, the container storage interface has been designed and I think introduced to Kubernetes. It's because exactly what you've said is to solve the scaling problem, and and the most important is to solve the dynamic provisioning as well. So then, and what happens with not just the dynamic provisioning is to provide data protection capabilities, disaster recovery, having a scheduler that it's not in tree, it's a plugin that any vendor can go and follow the standards, which is pretty. I'm not gonna say pretty straightforward, because there's a lot of technicality and and coding and programming and thinking and designing around it. But think about it this way. So the plugin standards is from a vendor perspective who have already a product that's providing data storage. It's going to be file, object, block, whatever beneath it. So it's just the ability to say that, can you create me a volume? Can you update it? Can you remove it? Can you delete it? Right? So just think about it this way. So this is what the CSI plugins interfaces start to introduce to Kubernetes. And all those vendors who have already been innovating in the storage area, whether they're going to be whether they're going to be a tier one products that providing fast tier or fast NVMe disks, to those companies who are providing archival, or other companies who have already been dealing with data protection, backup and restore, and disaster recovery solutioning, right? All of those companies, they can provide their own plugin that the customer can use and can combine whatever use case they want to do, right? Let's maybe
Sure.
mention one example. So think about it this way, and hopefully the majority of the audience is aware of AWS because it's a common one and everybody is using it. And I use it personally because it's easy to access and to pay as you go, whatever
You just
public
have to
cloud
turn
will
off your
say.
instances. You have to remember to turn off your instances, or else you get a
That's
big bill.
that's that's one thing. The other problem, I think, this is not related to storage, but I think it's kind of touch base with storage, is the fact that I think most of the enterprise bills comes from not running the compute, but from the egress and ingress charges between
Yeah.
regions and availability zones. I think that's the secret killer of all the public cloud and hybrid cloud and multi-cloud and your cloud kind of problems. This is this is one of the major issues. So okay, back to storage, it's CSI. So the example of AWS, like think about it, yet you have your compute nodes. I'm not gonna say EKS or any buzzword now. Let's just stick with, you have compute nodes, virtual machines that you're running your Kubernetes on. You have your controller plane and you have your worker nodes. The worker nodes, usually, this is where we're gonna be trying to to attach our storage to, because this is where the boss is going to be created and deleted and replaced, and whatever life cycle of that bot is going to happen, right? So there is the ability of you creating and dynamically block or file services, or let's call them objects, from the provider themselves. It doesn't care that it's AWS or Azure, it's wherever you are running your worker nodes. And then the control plane is going to start like to schedule to orchestrate your storages. So if I want to create a new bot, I'm not gonna spoil whatever I'm gonna be saying in the slides, but if you're gonna creating your bot, a resource is gonna trigger or communicate with the cloud provider to create you a block disk. That block disk is going to go all the way to your bot and map to it, so that you're going to have a direct access to the block. And if you're going to be recreating the bot or destroying it and creating a different node, you still have the same block disk that's going to be attached to the bot. So that's one of the benefits of CSI. I don't want to go with other stuff, so let's stop there.
And I just want to add one thing to add too, is because we keep talking about CSI and vendor. There's also little projects where you can just do this on your laptop. So for instance, if you have Minikube, which is a mini version of Kubernetes, especially for people who are just learning, it has a local path driver, CSI, which means that you can enable that add-on, and then you can ask for storage as you would do creating a persistent volume claim, which automatically says to the Kubernetes cluster, I want storage. And this is where the CSI will say, oh, okay, dynamically, here it is, the storage class. So it doesn't have to be, some big, there are ones out there which are just open source. You can download them to your laptop too.
I agree with you. I haven't done anything with Minikube, except that I just run it once and delete it. But I think that's when let's be, if we're gonna be thoughtful about what if new people's coming here, Minikube is it's a really nice starter. It's easy to handle. It's you can run it on your laptop machine. You don't need to have a virtual machines or other subscription on public providers to have.
And runs on
Cool.
Windows, Mac,
So
and all the, so yeah, that's the other thing too, is because a lot of Windows people say, well, I can't run Kubernetes, but you can. I'll also add though, Rancher Desktop is good too, but Rancher Desktop does not have by default the CSI driver. It will give you dynamic storage, but the local path one doesn't have a snapshot. You'd have to add that. Anyways, I'm going too deep.
Yeah, absolutely. Actually, Rancher Desktop was in my mind to say that. It's like, yeah, should I
Yeah,
say
I'm
it?
reading your
No,
mind. It's the
it's
glasses
good.
they reflect. Yeah.
It's the glasses that reflect. Exactly. So if I'm gonna go and select, oh, there is select a tab. Awesome. Um, so I create this few slides very quickly just to look at what the agenda we have. We already covered the first part, which is why does Kubernetes storage matter, and from stateless to stateful. The other thing I think we touch base on very quickly, maybe we can follow on this is, oh, I have animations, don't worry. So when you're running your stateful applications, give me a second.
Mhm.
So when you're running your stateful application, there's always the fact that um, I can keep, okay, I think before I'm gonna go with stateful applications, I think Jeff, you might give me more examples. I'm gonna give you one example. It's
Sure.
databases, right?
Yep.
Database is a huge part of people are still resistant to Kubernetes because people, enterprises and a lot of huge customers, even mid-range customers, they've been using virtual machines or bare metal, which is like the physical server, to install your operating system, install your SQL or Oracle database, and then you kind of keep it there. And you always, every morning, you wake up to check on it and pray next to it and make sure that it's still up and running 24/7 because like your business is relying on it, right? And you can still run your stateful application there outside of Kubernetes. Think about this way: there's the database stack and there's the application stack, the front end, whatever you're gonna call it, right? So you still can run your application, the databases, sorry, outside of Kubernetes, but you would end up with every time you want to re-architect or you want to refactor, um, it's not going to be part of your project anymore. And you have to maintain that legacy stack in a parallel. That means that you're going to have another staff just taking care of it, all this stuff, right? So that's
Expertise.
not convenient.
Yep.
I don't want to go there because DBAs are
Yep.
another breed of human beings, right?
Especially Oracle.
Exactly. Yes. Um, the other option is to run your stateful applications on top of a cloud service. Like there's a lot of managed databases that you can have with the cloud providers. They're very easy to set up. Double clicks. They already they have a lot of elasticity, which is a huge part of going to a kind of a cloud native or going to an app modernization because sometimes you need to scale up and sometimes you need to scale down based on the demand, right? However, there are a lot of vendor lock-in stories that we've heard from a lot of people. Once you get there and you just stuck there, and also the performance and latency, it's always there's customization and tweaks which is you don't have. So this is why it's not a great story to stay there. The other one, which is you can run them. Oh, sorry. The other one is you can run them on Kubernetes, right? I think even Oracle, and since we mentioned it, which is one of the I think the troublesome, cumbersome databases to handle, has its own container image, has its own Kubernetes image, right? So you can just go and install it from the registry and then you can just run it. Yeah, it still has some problem with file mapping and it's hard to migrate and run back, but it's still the hardest database has been containerized and it's easy for you to keep within the same stack and the same staff can take care of that. So that's going to bring a lot of flexibility to your workflow. With that, I'm gonna be switching to, since we talked about storage, I thought we're gonna maybe gonna have some time, but I don't think the hours is almost there. To talk about Docker storages, then we're gonna move to Kubernetes, but
Sure.
I think that's gonna be enough.
Yep.
So with Kubernetes storage, there's three main types. There's the ephemeral volumes, which think about them as the a local path, or I don't want to say local path, maybe the temp-fs with Dockers. So it is just a temporary file system that's going to be within your container. in Kubernetes, we call them empty directors or empty dir. And this is what we're going to be seeing in the demo, maybe, hopefully. So the problem with that, it's once the volume, once the pod is created and if it's destroyed, it's just going to vanish. It's just going to evaporate. Your data is lost, right? So this is one thing, actually. There is a lot of deployment that relies on ephemeral volumes because the data, it doesn't have to be persisted. And there's other mechanisms to offload your data before you destroy your pod, or your pod is going to crash. But we don't go deep diving into this stuff. The other one is projected volumes, and I've seen actually, to be honest with you, I know about secrets. I know about config maps as a Kubernetes resources. Secrets is where you store your secrets, which is not convenient. There's other options out there to make sure that your passwords, your tokens are very secure. But let's take it this way, in a very basic way. There's config maps. Also, this is where you can store your key value configurations of your application. And those two resources can be projected inside a pod, and they're kind of outside the life cycle of the pod. And I came across projected volumes, I think, recently. I didn't know what they're really calling them. So they're calling them projected volumes. And when you're really writing your descriptive YAML file, you call it like a projected and then secret and config maps. So yeah, that was something that I've learned as well. The last one is the persistent volumes, and this is what we are after, especially with databases. The date when we care about the data, and when the data has to be beyond the lifetime of the bot. Anything you can add here, Jeff?
Yeah, I mean, one thing just for interest, because people sometimes don't realize this. So people say, well, what secrets in configs maps? Well, config maps, yeah, there's like environment variables, you can use things like that, and secrets for your secrets. However, secrets in Kubernetes are not encrypted, okay? So it's not that, oh, good, I put in my secret and I'm happy. No, you really, if it's production level, should leverage something like, there was HashiCorp, I think, there's all sorts of stuff. But keep that in mind, that secrets, if you have access to a Kubernetes console, you can, they're just encrypted, they're base 64 encoded, that's all. So keep that in mind. And the other thing too, I'll mention is with ephemeral volumes, that was always the argument for about containers. Well, containers are stateless, right? They just blow up. And this is the big change that's happened, relatively recently, is with persistent volumes. That has changed. That is putting Kubernetes more into in a world like virtual machines were before. So, and final thing I'll add is people back in the physical days used to say, oh no, we'll never put a database in a virtual machine. That would be horrible. And so you're hearing the same thing now, and I bet you 5 years from now, that'll go away.
I agree with you. All right, so with that, we can go into a demo, right? Because things can be way easier when we know the demos. I have a few demos. Maybe we're just gonna focus on one. Do we still have some time?
Yeah, about 15 minutes.
Okay, awesome. So the first demo is just to talk about how you can create an ephemeral volume, right? So in this demo, we're just gonna create a bot, and then we're gonna restart the bot and validate the data does exist or not, right? So I made a mistake. Let me just share the whole screen. It's gonna be easier. Good. Let's continue this side.
I like the folder name.
Oh, of course.
Korner.
Yeah, I have to be thoughtful about this stuff. Yeah. I believe I have everything installed here, but maybe I'm just gonna go walk you through the YAML file itself. So something I really like about Kubernetes, especially if you can run it, if you want to create a resources or an object, there's always the imperative way rather than you writing the YAML file, and that's a huge tip if you're really gonna do the CKA, the Kubernetes Certified Administrator, or whatever version of that is. is to learn how to do the imperative way of things because you don't have the time.
Yeah.
But now we're just gonna stick to the descriptive because I just want to make sure that everything working. So inside the demo one, I have a YAML file. If I get that, so here, what we're gonna be what are we gonna be creating? We're gonna be creating a bot. We're gonna be calling it HTTP server. And I thought about it this way. So the volume that we're going to be creating, as you can see here in this spec block, the volume is going to be shared within the bot. And this is what one of the benefits of empty directors, which is you can use them between containers within the same bot, and think about it as the sidecar kind of topology,
Yep.
or maybe the init containers where you just want to initialize the container first, prepare whatever content or configurations of the container itself, and then just pass it to the container. So this is one thing. So the init container is just gonna make sure that is write something to the data file, to the index.html, since we're gonna care about the HTTP server. And then when the other container is gonna run, we have that file is gonna be already mounted to this path.
So basically, what
So
you're doing
let's,
here, I'll just explain, is what he's done. He's
yes,
creating an init container, which will come up first. It will write that echo website initialized successfully to the data index file HTML, and then the other container
yes,
comes up, which is the HTTP container, which is a web server, and that'll be
yes,
there in that file. So if you go to
yes.
the web
So
page, you'll see that.
absolutely. So this is one useful thing that we can do with IP directors, especially like if you have this kind of scenarios, because who's gonna care about ephemeral volumes, right? When you think about it, like everyone is gonna do persistent, but no, it has its own what's it called that use cases.
Yeah.
Especially the other use case is if you're going to be running the sidecar kind of topology where logging between both is like one container is sending a log and then the other one is parsing it, something like that. So let me just make sure that my bot is created and it's created and running. If I go and get inside it, so I'm going to exec in HTTP server and stdy, stdn, and I will go as a shell. So I'm inside the container, which is the default one. I should have mentioned it here as a -c httpd, but I think we just got inside it already. And when we go to var www html and we ls, we can see we have the index, and if we can have that data is survived the first container, and then it's still within the life cycle of the container, right? The other problem is we're going to have now, if this file were this empty director, which is just the temporary file system, you think about it this way, once we delete this is going to gone. So this is one thing we don't want when we want to persist the data, right? Right. So if we're going to go to the next one, is to create the projected volumes bot. With that, we can create a secret, a config map, and then we can jump to create a bot and validate that projected config object is going to stay beyond the lifetime of the bot itself. So this is exactly what we're going to be doing. And if we're going to go back here, I don't think we have any, I don't have the object YAML files of the secret or the config bank ready, because I think it's nice to show people that there is imperative way to do that, right? So if I do secret, which is you don't have to do that in front of the Actually, I just realized that I'm still inside the shell of the container. Nice.
He would have complained, yeah.
Okay. Yeah. Um, so first thing first, I need to create a secret, and you don't have to create secrets in front of people, so don't do that.
Especially if you're using your
Sometimes I
credit card
forgot.
now.
Exactly, right? So sometimes I forgot how to do this stuff. It's okay because we can just use the help. And then
It's
I'm
really
gonna
important to
go.
learn too for the exam, because you can go to the documentation, but sometimes just using the command line help will save you.
Exactly, and I think I have one example where we're going to be going to the documentation because this is very helpful to learn how to access this stuff. So for a secret, I just need to, because I'm not going to be reading a secret from a file, or I'm not going to be passing a file to. I just need a from literal key blah blah blah. This is the format I'm trying to do. This one, right? So I'm just gonna maybe pick both, maybe one, maybe just one. And then I just need to write it here. And let's be more thoughtful about that. Maybe this is my password for my application. It might be my Postgres database, and this is what I'm going to be using.
Mhm.
And let me call that the Kubernetes Corner
Excellent.
secret. Right. So it's been created. I don't think we need to do the other one. So let's go and move to creating the bot itself. So maybe let's just a good time to just copy paste the stuff. So if I'm gonna go vi projected bot.yaml, and let me just copy paste my stuff from here. Okay,
Yep.
so my YAML file here has a container, a BusyBox image, which is going to keep running endlessly. And inside that, I have my volume. Outside in my spec, I have a volume, and within the volume, I have projected. So within projected, there's two types of projected. There's a secret, and there's a config map. And those just take care of, let me just get your object secret or an object config map, and then I'm gonna pass them as file paths inside your bot, inside your container. And this is exactly what I'm gonna be doing. So I think we have the same. You have to make sure that your secret name is the same, and then your key is the same. So it's gonna be mounted directly to app/password in within the projected volume director into this bot. So if I do k apply
Mhm.
minus f project YAML, I have it's created. I'm just gonna make sure that it's running. Oh, not priority, um,
Mhm.
but projected, and it's running very quickly. I'm just gonna go into k exact.
And I'll say to people, why would you want to do this, for instance? So I'll give you an example. On MySQL database, you have to have that password for the MySQL, or else it won't start. So if you're creating it in Kubernetes and in a container, it'll come up and it'll start creating the container, and then it'll come up with container create config error, some blah blah blah, because it doesn't see the secret. So that's an example of where you have to have that information in the container so they can see it and read it. Otherwise, your application won't work.
Exactly. So I just got inside the container. I have my app. I have my password. Hopefully, if not, I did something wrong. So ls, I have my password because
There
now
it is.
it's a file. So I'm gonna get, and I have my, sorry, it just got messed up. So this is my super secret that I've passed as a secret object. All
Yep.
right. So let me go back now. Let's do the last one,
Mhm.
which is the most interesting one. And take it this way. This is a very basic persistent volume. There's more stuff you can do. And for that, you can follow that example I have here, which is I've used with all the exam questions I've had. So every time I have a, can you create a persistent volume? Can you do secret storage class? Can I do a persistent volume claim? I've done that. So just to give you a bit of concept here. So this is a static provisioning, means that I have to prepare my persistent volume before and then I have to create a BVC, which is, think about as the request to claim that piece of storage. So this BVC is going to be used by the bot itself, and it's just going to make sure that, hey, I need to claim 10 gigabyte, and if I have statically or manually provisioned a 10 gigabyte of storage, this BVC is going to go and claim that BV or persistent volume, and this is going to mount it to the bot. If the bot is crashed, the persistent volume is going to remain running. It's going to remain until you're going to create another bot, and which is you can just use the same workflow and you can read the same data you have persisted before the first bot is crashed, right?
Mm-hmm.
So in order to do that, very quickly, we're going to come back here. I have a couple of stuff that I can just copy paste because we don't have time to go through everything. And as you already mentioned, we're going to be using something called local paths. Means that we're just going to be, or I think we call them host path in Kubernetes as well. And to do that, let me just VI, or let me just do this very quickly, easily. So think about it this way. We're going to create the persistent volume first, which is, I'm going to call it my volume. Storage class name, it's just a matter of, we don't care about now. We're going to care about it more when we're using dynamic provisioning. And I think this is a bit, oh, sorry for that. I think I messed up something there. Let me recopy. And it's created. So read write once is kind of the access modes I can give as a policy to my persistent volume, which means only one node, one bot is going to read write on top of this. But then you can have multiple access modes to the same BV, because this will be controlled by the BVC itself, or maybe from the source class in general. However, this is the path I'm going to be putting my data. This is the host path. That means that this data will be created in this node, the node actually where the bot is going to be created. So this is one thing is going to maybe prevent you from scaling to other nodes and stuff like that. And you can solve that with dynamic provisioning, or maybe having a one interface share that your host path is going to be shared to. The last thing, not the last thing, the second one is the BVC, which is the persistent volume claim, where I'm just saying that I need to request this 4 gigabyte of storage. If I have it already, so if I'm gonna say get the Kubernetes, get the BV, I have this 10 gigabyte, and sorry I didn't show you the status here before. So before I create the BVC, it's just here like as an available. So it hasn't been claimed yet. But after I create the BVC, it's just now showing that it got claimed or bound to a BVC. Now that BVC can be used by a bot itself. So let me just go and copy that bot YAML file. And as you can see here, the bot is running a busybox because it's the simplest. And you have to have two things in here. A volume spec block, which is kind of mapping to the BVC claim. And also inside the container, you have to add the volume mount block, which is where you want to mount that volume inside the container itself. And you have to this name of the volume mount has to match this name of the volume itself. So this means this is what you have to recognize this. The bot itself is gonna map those two blocks together. If I'm gonna go to create bot, I can see that my busy box, I think I called it. And if I'm gonna go to key exec to my busy box, client ID, and I can go now to cd etc foo, and inside here I can just maybe touch data, right? I can
Yeah,
do
make it
that, right?
something crazy so we'll be able to.
I know, yeah. So now what I'm gonna be doing, I'm just gonna okay the delete. Oh, you wanna do the replace? I think I haven't done replace in a while. So oh, let's keep it simple. So
Yeah.
okay delete but which is busybox, and can you do it with force because we need to do that very quickly. It's being deleted.
Mhm.
Now, if I'm gonna recreate the same bot, I'm gonna wonder, did my data persisted or not, right?
And he used the force there. That's from doing exams, because when you do a normal cube delete pod, it has like a 10-second whatever. And during an exam, you're sitting there going, no, I'm running out of time. So you do force and it kills it right away.
Absolutely. Thank you for, we're doing kind of a semi-storage and
Yeah.
CTA exam
This
tips
brings
with the
back
same.
exam nightmares. The first time I did the exam and I didn't know about force, and I'm sitting there,
Ooh,
the clock is ticking and my pod's not deleting, right?
yeah, absolutely. So I just get back to the new one and ta-da, I have my data.
Persistent data, persistent. Yes.
Absolutely. So now I'm gonna be struggling to stop the. Oh no. Okay, found it. Nice. Found myself back. We're at the top of the hour. I think thanks to the people who stick around to see the demos.
Yeah, I mean, if there
And
if
you
there are any
can.
questions, folks, because we kind of run out of time, just send them. Let me just think. Well, join the Kubernetes hub or the Cube Corner hub on the Veeam hub. You can ask any question there. And like what I do sometimes, if I'm worried about my questions, I make up a phony name and I call myself someone else. Like I take my boss's name and then I ask the question, and everyone thinks it's a dumb question. Well, no, I don't do that. I'm joking. My
Jeff,
boss might be watching, but
I'm
yeah.
sorry to interrupt you, Jeff and Adam. There is a question. Maybe we can just give it
Oh,
like
sure.
a minute to answer that. Can you please explain about read write once, read
He did
write many,
actually.
and
Yeah.
read only many?
Yeah, he actually
Uh,
explained that, but we go again.
Absolutely.
Yeah,
I can explain very quickly. So read write once, it's just kind of the access modes that you have on your BV. So read write once is when the volume can be mounted for both read and gun write by a single node at a time. So this is why it's saying once. So it's a single node at a time. For read write many, it means that many nodes can access the same BV, which is you have to be careful because your storage has to support that shared access
yeah,
unless your data is going to be corrupted,
yeah,
which is usually what we do with file services. And the FS shares, you can do write mini because
yeah,
there's a guarantee that it's not going to screw it up. The last one is the read only. Read only mini means that the volume is just going to be multiple nodes can actually read it. So yeah, you have to. It's not one node.
Hello.
Hi.
Yeah, so basically it's a node or it's a pod.
oh, yep, yep, yeah. The
Um,
terminology,
uh,
yeah.
the,
And
the terminology, I think the read write once is a node. I think, if I'm not.
I think
Yeah.
I think what I think because if I was just reading about this the other day, pods. If you've got read wide once, then whatever pod that's been connected to, that kind of takes command of it. Where if it's many, then many can. But of course, the danger is, as you said, that if your storage provider doesn't support it, it can get all messed up. And so I think, like you were correct, NFS that supports it. I haven't really used read write many because I haven't had a use for it, except for, of course, the exam where you have to learn this stuff, at least once. But yeah, so
Usually you're gonna tackle this kind of problems when you're building some distributed database applications where a couple of pods going to be residing on a couple of nodes and going to be reading and writing from the same
exactly, yeah,
solution. And for that particular thing, you can go with the hard way and you can go with the easy way. And there is a lot of cool storage kind of platforms that kind of abstracting that problem from you. I'm not going to be calling names here because we're trying to be vendor neutral, but that's Jeff thing. He can say these things. I would like to be invited again, so I'm gonna keep with the rules.
No, no, yeah. No, we just, what we like to do is as I said, we're the Kubernetes corner. We try to be, what you call it, like a Kubernetes focus. So even though I've got my Veeam hat on, I'll cover it up. That's just because, hey, I'm cold. It's snow outside. Had to put something on, and the first one I found.
Let me
But
just
that's
let
why
me just
the more swag you send me from different companies, hey, if everything's in the wash, there's a big chance that I'll put it on, right?
Yeah, exactly. You have to orchestrate this swag, right?
Or
And schedule them.
whoa,
I
that's
know.
orchestrate the swag. You know what? You've given me a great idea. Swag orchestrator. I can patent that.
Nice. Awesome.
Kubernetes. There we go. I'll put your name in there too. Okay, folks. Well, we're at 5 minutes after the hour. We actually started 5 minutes late, so I think we're okay, Madalena. Like we didn't overuse our bandwidth or whatever. But this was a fantastic session. It was deeper than session than usual because we've got such a excellent storage expert and programmer and everything. So we took advantage of that, and I hope it was very interesting for you. And again, if you have any questions, if anything wasn't, because the first time I looked at this stuff, CIS, I looked at it and I was like, whoa, spaghetti. I didn't know what it was. So don't feel bad. Use the Kubernetes corner at the hub if you want to ask questions, because we're all there hanging out, and yeah, and we'll see you next time. So thank you very much, Adam. This was fantastic. And I know it's probably
Thank
evening
you,
there
Jeff,
in
for
the Czech
having me.
Republic. You're probably going to want to have a beer, because why not if you're in Prague? But okay, folks, we will see you next time. Thank you very much.